Hello students, welcome to my channel. Today I am going to discuss about basic efficiency classes. So in the last class we have discussed about asymptotic notation. So let's see one by one the basic efficiency classes. So these classes are listed in the following table in increasing order of their orders of growth. Okay, so let's see. The first one is constant. For constant, the order of growth is order of 1. So the running time does not change with the input size. Then the time complexity of the algorithm is order of 1. Okay, if the algorithm is taking constant amount of time for problem solving, then the time complexity of that algorithm is order of 1. Okay, so the example is the number is even or odd. Okay, to find out the number is even or odd. So let's see, the input value is 8, so it will take some amount of time. If the value is 150, it will take same amount of time. So here the task is the algorithm needs to check whether the number is even or odd. So whatever the number, it will check, it will perform the same operation. It will check even or odd. Okay, so it is taking constant amount of time, so that's why the time complexity is order of 1. The second one is logarithmic. So for logarithmic, it will take order of log n. So the example is binary search. So in logarithmic, the result is cutting a problem size by a constant factor on each iteration of the algorithm. Okay. So the example is binary search. Why? Because it halves the problem size with each step. Let's see. So this is the binary search. I want to search for 23. First we need to find out the middle value. So how to find out the middle value? First plus last divided by 2. So first value is 0, 0 plus 9 divided by 2. It will give 4.4. Sorry, 4.5. So the middle value is 4. I mean, middle value is index value 4. So compare 23 greater than 16. Is it true? Yes. So if the search element is greater than the mid value, we need to concentrate on the second half. If the search element is less than the mid value, we need to concentrate on the first half. So the search element is greater than the mid value. So we need to concentrate on this half. Next, we need to find out the mid value. So what is the starting value? 5. Ending value is 9. 5 plus 9 divided by 2. So it will give 7. Okay. So next we need to find out 23 is less than 56. Next we need to concentrate on these half. Okay. So the search element is found. For every iteration, we are dividing the binary search into equal parts. For these type of problems, it will take time complexity order of log n. Okay. The next one is linear. Okay. So if the algorithm is taking time based on the n value input size, it will be order of n. Okay. So sequential search is the example. Let's see. So we all know sequential search, linear search, one after another. In this, I want to find out to 20 element. So it will search first element, second element, third element, fourth, and so on. Okay. If it contains 100 elements, in linear search, it needs to search all other elements. If the array contains 10,000 elements, it needs to search every element. So here the time is dependent on input size. If the input is 5, it will take 5 amount of time. If the input is 10, it will take 10 amount of time. So that's why the time complexity is order of n. The next one is linear arithmetic. Okay. So there is a difference between logarithmic and linear arithmetic. The this algorithm divides the problem into smaller pieces and solve those smaller pieces independently and combine the result. Okay. So example is quicksort and merge sort. Let's see the merge sort. So this is the array. We need to sort by using merge sort. So what is merge sort? Divide the problem into equal parts. Okay. So 2. Next divide the problem into smaller pieces 36, 27, 43 and 10. Next solve these parts independently. So 38, 27. What is the least number? 27. So it will interchange. 43, 10. What is the least number? 10, 43. Next, in this 27, 10. What is the least number? 10, 27. And after that 38, 43. What is the least number? 38 and 43. So if you observe in merge sort, the algorithm often divide the problem into smaller pieces, solves those pieces and then combine the result. For these type of problems, the time complexity is order of n into log n log n. Okay. So the next one is quadratic. Okay. So the algorithm takes, so for this, the example is bubble sort, insertion sort and selection sort. Let's see, it will take n square times. See this one. 7643. I think you are aware of bubble sort. So in bubble sort, first it will check two numbers. If the first number is greater than the second number, it will interchange. Next to two numbers. If the first number is greater than the second number, it will interchange. Next to two numbers. If the first number is greater than the second number, it will interchange. After first iteration, the first number is stored in the greatest number stored in correct position. After the second iteration, the second highest number stored in correct position. After third iteration, third element placed in correct position. This is known as bubble sort. For this type of problem, it will take time order of n square. Okay. So the next one is cubic. So the example is matrix multiplication. So in matrix multiplication, so this is two rows, three columns. Here, three rows, two columns. First row, first column, first row, second column, second row, first column, second row, second column. So in this way, the matrix multiplication operation will done. Okay. So the time complexity for this type of problem is order of n cube. And the next one is exponential. So that better example is towers of Hanai. Okay. Let's see. So this is the towers of Hanai. So we need A, B, C. A is known as source, C is known as destination, and B is used for temporary purpose. We need to move all the disk from source to destination with the help of temporary disk. Okay. So first we are moving red to destination, next white to B, next red to B. Why? Because here the big disk can contain the smaller disk, but it is not possible to keep the large disk on small disk. Okay. So in this way we can solve the problem. For this type of problem, the time complexity is order of 2 power n. And the last one is factorial. We all know for factorial, the time complexity is n factorial. For example, if we want to find out the 5 factorial, 5 into 4 into 3 into 2 into 1. So it will take n factorial. Okay, so here the example is traveling salesman problem. So the salesman needs to order the goods from source to destination. So if you see, so it is little bit clumsy. Okay, and this is the right path. So for example, this is the source. If this is the source, he needs to travel from one location to another location and return back to the same location. Okay. So for this type of problems, it will take n factorial time complexity, order of n factorial. I think it is clear what are the different types of basic efficiency classes. If you have any doubts regarding to this video, please comment me in the comment section. For more videos, please do subscribe my channel. Thank you.